Okay, let's get started. So we're going to start with section 3.3, and then we'll stop with just two sections, 3.3 and 3.4. Okay, so 3.3, there's really only one type of problem that we're doing from this section. So say if we have some type of parabola, maybe it looks like this. All right, the point here at the very, very bottom. Actually, we should draw this smaller. I need to draw two of these. Let's draw one graph over here. So maybe this one looks like this. And then let's also draw one over here. This one could look something like that. So one going up, one going down. So basically, let's call this point A, B, or maybe A1, B1. And this point up here will be A2, B2. So in either of these situations, both of those points are called a vertex. So above, so we have a vertex, which is basically just like the bottom if it opens upwards, like we have over here, or it's the top if it's going to open downwards. So the vertex are both of these points, A1, B1, and A2, B2. Another thing is something called the axis of symmetry, which is going to be this dotted line that cuts the parabola in half. And basically, here's the point A2. Here's the point A1. So the axis of symmetry is just going to be x equals, and then whatever the vertex is, the x part of the vertex is. So in the left one, it's going to be x equals A1. Let's do, like, this is going to be called, here we call this the left, this is the right. So we'll say this is the right vertex, this is the left vertex. And so the right, oh, sorry, I have that backwards. And then the left axis of symmetry is going to be x equals A1. So it's just the line x equals A1, which is the vertical line that goes through the x value of A1. And on the right, it is x equals A2. So just on a picture, that's what these two things mean, the vertex and the axis of symmetry. So say if we're just given an equation, f of x is equal to ax squared plus bx plus c. So this is just a quadratic equation. It's quadratic. Or in other words, a parabola. So say if we're not given the graph, but we still want to find the vertex and the axis of symmetry, and we're just given our equation. So there's going to be a couple of formulas that we need to have memorized. So the vertex is going to be this point, what is it, negative b over 2a, or something like that. 1 second, I'll look it up. Yeah, negative b over 2a. Let's make this parenthesis a little bit bigger. And then f, and we plug that number inside, negative b over 2a. So that's going to be the vertex. And then our axis of symmetry, so basically this is f, and we're plugging in this number inside of f. I wish we'll do this with an example in a second. And then our axis of symmetry is always just x equals whatever the x part is of the vertex. So x equals negative b over 2a. I believe that's really all we need for, oh, I guess also too, so if we look at this picture above, this vertex is either going to be like the biggest value of the graph or the smallest value of the graph. If we look on the left-hand side up here, the vertex is the smallest point on the graph because the graph just keeps going up to infinity over here and then infinity on this side as well. And if we look on the right-hand side, the vertex is going to be the biggest point of the graph because the graph just keeps moving down over here and down over here forever. So depending on the situation, the vertex is either going to be a maximum or a minimum. So let's give those like criteria. So let's write it like this. When is the vertex? A max or a min? And so if we have the A value above being bigger than 0, let's make that sign look nicer. So if A is bigger than 0, this is going to imply a minimum. And if A is less than 0, this is going to imply a maximum. Okay. That's basically kind of all the 3 things we need to answer the questions in this section. So the first bit of questions, which are basically the same, there's ones like 3 through 16, and then 31 to 40. I believe that's all we needed here. So 17. Wait, what sections? Oh, 3.3. Yeah. Okay, so let's just do one like, how about, let's do 12. So for the following, let's just write this down. Actually, I'm going to do that. So for this one, we're given, see, f of x is equal to 2x squared minus 10x plus 14. And there's a couple of things. We want to find the vertex, axis of symmetry, and determine whether the vertex is a max or a minimum, and then graph the function. So let's start with the vertex. That was the first bit. We want to find the vertex. So if we look above, we got to find 2 things. We need to find negative b over 2a, and then plug that number inside of f of x. See, we have to find negative b over 2a, and then we're going to plug that number inside of f. So let's see, what is negative b over 2a? So negative b divided by 2a is equal to, so remember, this is ax squared plus bx plus c. So in this example, we can see that our a is equal to 2, our b is equal to minus 10. Let's see if we copy this down right. Yep. And then our c is equal to 14. So negative b over 2a is going to be negative 10 divided by 2 times 2, which is going to be 10 divided by 4, which is going to be 5 over 2. So there's our negative b over 2a. It's going to be positive 5 over 2. So now what we need to do is we have to plug that value inside of f of x. So f of 5 over 2, this is going to be 2, 5 over 2 squared, 10 times 5 over 2, plus 14. So this is going to be 2 times 25 over 4 minus, and so here we have a 10 on the top and a 2 on the bottom, so those cancel. So it's like we have a 5 on the top, and we still have that other 5, and then plus 14. Okay, so now this is going to be 50 divided by 4, or what we can say this is going to be 25 divided by 2, minus 25 plus 14. We need to get common denominator. So 25 over 2 minus 50 over 2 plus 28 over 2. And so see, 25 minus 50, that's minus 25, plus 28 is 3, so 3 over 2. Okay, so now we found, and this is, again, this is equal to f 5 over 2. So now we know that our vertex, all we need to do is set point. So vertex is equal to negative b over 2a, f of negative b over 2a. And then from calculating above, we saw, well, negative b over 2a was positive 5 over 2. And then when we plug that value inside of f, we got 3 over 2. So this is going to be our vertex. And so now B, which is the axis of symmetry. So the axis of symmetry is always just x equals the x coordinate of the vertex, which is 5 over 2. The x coordinate of the vertex is right here, 5 over 2. So it's just x equals 5 over 2. Now, is the vertex a max or a min? All right. Well, here our a value in this problem was 2, which is bigger than 0. And then when we said previously, when the a value is bigger than 0, this implies a minimum. So it's going to be a min. And now we want to sketch the graph. So sketching the graph here, all we really need here is the vertex. So we'll go onto our graph, the vertex of 5/2, 3/2. So somewhere over here. Here's 5/2, 3/2. And we know it's a parabola. And because this a value right here, the a value is 2, which is positive, that tells us that it's going to open upwards. So it's just going to look something like this. And so the last thing that we can talk about maybe is intervals where f is increasing and decreasing. So all we do is after we graph it, we just look at the graph, and we know as we move from left to, so we were looking from left to right. If we move up, it's increasing, and if it moves down, it's decreasing. So if we look from left to right, so here's the x value of 5/2. If we look in this direction from left to right, we see the graph is moving downward, so it's decreasing until it gets to 5/2. So what we can say then is that it's going to be decreasing. And we're talking about x values here. So all of these x values all the way up to 5/2, the graph is moving downwards. So you see as we look from left to right, so as we're moving in this direction, the graph's going down, 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 and that's all of these x values from -infinity all the way up to 5/2. So the decreasing is going to be -infinity to 5/2. And then increasing, that's when the graph starts moving upwards. Well, as we start at 5/2 and we move to the right, as we keep going in this direction, the graph goes up and up and up and up and up forever. So the x values is just everything to the right of 5/2. Okay, so decreasing, increasing. And that's all we need for this problem. So which ones do we have to do? So up to 15. So those are all the same thing. And then 31, 33, and 39 are also the same thing. So let's just do one more together. So basically just the same problem. Let's do 35. So we want to do the same thing, but we have f of x is equal to -1/2 x squared plus 5x minus 8. Okay, so again, here's our ax squared plus bx plus c. So in this problem, our a is equal to -1/2, our b is equal to 5, and our c is equal to -8. So we'll start with the vertex. So we need to find negative b over 2a. That's always the first step. So this is going to be negative, and what's b? So b is 5. Then all over 2 times a is -1/2. So this is just going to equal 5. And now we have to plug that into f. So f of 5 to find the vertex. So we need to find f of negative b over 2a. So whatever this value is, we need to plug that inside of f. So f of 5. So -1/2, 5 squared, 5 times 5, -8. So this is going to equal -25 over 2 plus 25 minus 8. So we need a common denominator. So -25 over 2 plus 50 over 2 minus 16 over 2. Okay, so we have 25 minus 16. What's that? 14? No. Calculator. Nine. So this is going to be 9 over 2. All right, so now we know what our vertex is. Our vertex is equal to, so negative b over 2a, which is 5. And then f of negative b over 2a, so plug 5 into f, and we got 9 over 2. So this is going to be our vertex. And then once we find the vertex, we basically already have the axis of symmetry. So let's do that real quick. all it is just x equals whatever the x part of the vertex is. So that's going to be x is equal to 5. Now the max or the min, or let's complete that. So is the vertex a max or a min? So is the vertex a max or minimum? And here our a value is minus 1/2. Remember the a value right here, minus 1/2. And because that's negative, this implies we have a maximum. Okay, so now we need to graph it. So to graph, we start just by putting the vertex. What was the vertex? The vertex is 5, 9 over 2. So 5, 9 over 2, somewhere over here. And now since our a value is negative, it opens downward. So it's going to look something like this. All right, so there's a little sketch of the graph. And then the last bit, let's do the increasing and decreasing. So the intervals for increasing, decrease. Remember, we look from left to right, so we're looking in this direction. So the graph's moving up, moving up, moving up, and it stops. This is an x value of 5. So it stops increasing once we get to our x value of 5. So the increasing is going to be minus infinity all the way up to 5. And then it decreases after that, you see, so then it starts moving down, down, down. So it moves down forever. So from the x value of 5 all the way to, basically all the way to infinity. So 5 to infinity. Okay, so that's basically good for this section. Those are the only two, well, those are the same problem. Those are the only problems that we need to do from this section. So let's finish up with 3.4. Okay. All right, so this section basically just different types of equations solving for x. So let's start with, say, for example, number 2. Here we have x plus, you're sure, oh wait, sorry, where's this? Okay, 1 over 3 minus 5 over 6 is equal to 1 over x. So there's several ways to do this. I guess one way we could start is we can just combine those fractions on the left-hand side. So we need to get a common denominator. The common denominator is 6. So we can rewrite this as 2 divided by 6 minus 5 over 6 is 1 over x. And then just combining the fractions on the left, we have minus 3 over 6 is equal to 1 over x. And then we could simplify the fraction on the left. That's just minus 1/2 is equal to 1 over x. And then what we would do here is we need to multiply both sides by x. So if we multiply the left-hand side by x, multiply the right-hand side by x. So what we get is minus x over 2 is just equal to 1. And then the last thing to do is multiply by that minus 2 over to the right-hand side. So then we get x is equal to minus 2. That's basically the those are the standard steps for this problem. Let's do 5. So on 5, we have 1/2 plus 2 over x equals 1/3 plus 3 over x. Another way we could do this problem, we can try to find, so we see 4 fractions here, 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 and here. So basically everything in this problem is a fraction. What we could do is find the common denominator and then multiply everything by that, and that will get rid of the fraction. So let's do that. So the easiest way to find the common denominator is just take all the denominators and multiply them together. Or sorry, let's say it a little bit differently. We look at all of our denominators, and then we're going to write them down and multiply them together, but we're not going to write the same thing twice. So what we mean by that is, so to find our common denominator, So we're going to multiply all of our denominators together, but we're not going to multiply the same thing together twice. So our first denominator we see is 2, so we put a 2 down here. The next denominator is x, so let's put an x down here. Our next denominator we see is 3, so let's put a 3 down here. And the next denominator we see is an x, but we already wrote an x, so we're not going to put that one down there. And if we multiply these together, we get 6x. So this is our common denominator. So one step we can do is just multiply everything in this problem by 6x. So we take 6x, let's multiply everything by that. And what this is going to do is going to get rid of all the fractions. So if we multiply everything by 6x, the first thing so distribute to the 1/2, we're going to get 3x. Then we're going to get 12, the x's cancel, equals. Then we are going to get 2x. And then we are going to get 18. All right, so now to solve for x, we can subtract the 2x over. So we get x plus 12 is equal to 18. And then subtract the 12 over. We get x is equal to 6. Let's do number 9. So this one says y squared over y plus 4 is equal to 16 over y plus 4. So for this problem, we're going to do that same thing. We are going to find a common denominator and multiply everything by it. In this problem, we only have one denominator. It's y plus 4. So let's just multiply y plus 4 by everything. And that's okay to do. We're just multiplying everything by the same thing, so the problem is not changing. Over y plus 4. So if we, on the left, we're going to get y squared. And on the right, just 16. So if we square root both sides, we're going to get y is equal to plus minus square root of 16. So y is equal to plus minus 4. So two answers. We have y is equal to 4. And then we get y is equal to minus 4. However, we need to check these answers. Oh, not 14, 4. So whenever we're dealing with the ones that have like squares or even square roots, we need to plug the answers back in to make sure everything's okay. And the only time something's not going to be okay is if there's a domain issue. So if you notice with y equals to minus 4, if we were to plug that in, this would make the denominator 0 here, and it would make the denominator 0 here. And we can't have 0 in the denominator. So for that reason, this answer, we're just not going to take that answer because it gives the bottom of the fraction to be 0. However, when we plug y equals 4 in up here, that doesn't happen. We never get 0 in the bottom of a fraction. So our only answer for this problem is actually just going to be y equals 4. Let's do... do 16. So 16 says 2x over x plus 7 is equal to 5 over x plus 1. So let's find our common denominator. So all we do is write down all of our denominators, but only one time each, and multiply everything together. So our first denominator is x plus 7, and our second denominator is x plus 1. So those are all our two denominators. That's going to be our common denominator. So we're going to multiply the whole problem by that number. So x plus 7, x plus 1. Oh, sorry, not equals. And then 2x over x plus 7 equals 5 over x plus 1. So when we multiply on the first bit, the x plus 7's cancel. So we just have x plus 1 times 2x. And on the right-hand side, the x plus 1's cancel. So we just have x plus 7 and then 5. So now if we distribute the 2x, we're going to get 2x squared plus 2x. And on the right-hand side, we'll get 5x plus 35. So let's get everything onto one side. So this is going to be 2x squared minus 3x plus 35 is equal to 0. So we need to factor this. So we could use the AC method. What we need to do is multiply our A and our C together. So 2 times 35, which is 70. So 70. And now what are the numbers that multiply up to 70 but add up to minus 3? So let's see, it's not going to be 25 and 3. So it's 70, oh, 10. So we can do, oh no, sorry. Let's see. This is we made a little typo here. This is a minus 35. See, we had a plus 35, we subtracted over to the left-hand side, so now it's a minus 35. So we need to multiply up to minus 70 and add up to minus 3. So that's going to be minus 10 and 7. So minus 10 times 7 is minus 70, and then we add those together, we get minus 3, which is that middle number. So what we do is now we write this as 2x squared. Why is this doing this? Oh, I was on the eraser. Okay, so we have 2x squared minus 10x plus 7x minus 35 is equal to 0. So what we're doing is just continuing to factor. And so we group the first two terms together and the second two terms together. So from the first two terms together, what we can do is take out a 2x, and we're left with x minus 5. And the last one, we can just take out a 7, and we're left with x minus 5 equals 0. So now what we can do is we could take out this x minus 5. And from the first term, we're left with a 2x, and from the second term, we're left with the 7. So that equals 0. And this first soap, we got x minus 5 is going to be equal to 0. 2x plus 7 is equal to 0. Here we get x is equal to 5, and here we get x is equal to minus 7 divided by 2. All right. What number was this? 16. So now we look back at the problem. Do any of these problems? So if you look here, you see like if we plug in 5, if we look back at the problem, that's not going to give us 0 in any of the denominators. So 5 is okay. We don't got to worry about that. Same thing with 7 over 2. If we were going to plug in this minus 7 over 2, here's the problem. If we plug that up here, again, none of the bottoms of the fractions are going to be 0 when we plug that in. So that answer is also okay. So we have these two answers. We have x is equal to 5 and x is equal to minus 7 over 2. Let's do 22. So in this one, we have 1 over 4x plus 12 minus 1 over x squared minus 9. 9 is equal to 5 divided by x minus 3. So let's try to find our common denominator here. So in order to find the common denominator, it's also helpful to factor all of our denominators. So the first thing we can do is let's factor this this first denominator. We can take out a 4, and we're just left with an x plus a 3. We can factor x squared minus 9. That's going to be x plus 3, x minus 3. And then there's nothing to factor on this last one. All right, so everything's factored. So now what we can do is to find our common denominator, like we said before, all we do is whenever we see something, we write it down. So the first thing we see is a 4, let's put it down. And we don't write the same thing twice. The next thing we see is this x plus 3, so let's write that down. Here's another x plus 3, but we don't write the same thing twice. So here's an x minus 3. Put that down, we don't have that yet. And here's another x minus 3. We already wrote that down, so we don't need to put that on there. So our common denominator is 4 times x plus 3 times x minus 3. So let's take that number, 4, x plus 3, x minus 3, and then multiply everything by that. 4, x plus 3. Did we write this problem down right? 22, 1, 1, and 5. Okay, we're good. X plus 3, x minus 3, x minus 3. So when we distribute across, the first things that cancel are the 4 and the x plus 3. So we're just left with an x minus 3. For the second term, the x plus 3 and the x minus 3 cancel, and we're just left with the 4. And then the last one, the x minus 3's cancel, so we have a 4 an x plus 3, and then a 5. This 5. All right, so what do we have over here? We have x minus 3 minus 4 is equal to, so 20x plus 60. Sorry, is everything, 1 second here. No, this one more time. Yeah, everything's okay. All right, so what we do now is we just solve for x. So we'll simplify the left-hand side. So we have x minus 7 is equal to 20x plus 60. And what we can do is we can subtract the 60 over and subtract the x over. So what we get is minus 67 is equal to 19x. And then we can divide by 19. So minus 67 over 19 is equal to x. Is that the right answer? So we're good. That's the right answer. Again, if you were to plug this back into the problem, here, the denominator is not going to be 0. So this answer is okay. All right, what other ones we got? Let's do 33. So this is going to be a different type of problem. We have here is the square root of 2x minus 5 is equal to 2. So whenever we have these problems, the first thing we're going to do is, well, we want to get rid of that square root sign. So what we can do is just square both sides. So what we're going to do is we're going to square 2x minus 5, and we're going to square 2. So the square root sign is going to go away. We have 2x minus 5, and that's going to equal 4. So if we add the 5 over, we get 2x is equal to 9. Divide by the 2, we get x is equal to 9 over 2. So now with these square root problems, we need to make sure if we plug this number in, the number on the inside is not a negative number. However, if we were plugging in 9 halves into this, the inside's not going to be negative. So this answer is okay. So just for this problem, our answer is going to be 9 over 2. How about... Which ones do we have on here? 31, 33, 39. Let's look at number 40. So number 40 has the cube root of 2x plus 1 is equal to minus 5. So in this problem, we don't square both sides because we have a cube root. So when we have a cube root, what we're going to do is actually cube both sides. So we're going to take, and that's going to help us, that's going to get rid of that, the cube root sign. So we have the cube root, 2x plus 1, take that to the third power, and it's going to be minus 5 to the third power. So we're just going to have 2x plus 1, we get rid of that sign. And over here, we have minus 125. So we can subtract the 1 over. 2x is equal to minus 126. Divide by the 2. X is equal to minus 126. Divide by 2. So that means x is equal to 63. Or minus 63. All right, let's do one more together. I have 55. So what 55 says is we have square root of x plus 4 plus 2 is equal to x. So this problem's a little bit different. Now we have like an x involved here, but it's still the same thing. So basically the whole idea of these problems is we have to get the square root alone on one side and then everything else on the other side, and then we square both sides. So let's subtract that 2 over. So we have x plus 4, x minus 2, and now we can square both sides. So let's square the left, square the right, and we're squaring now because this is a square root. This isn't a cube root or whatever, and we know it's a square root because whenever there's not a number written, like so say if we have like the square root of x, whenever we don't write a number, like before we had a 3 up here, if nothing is written there, that just means there's a 2 there. So if there is a 2, we usually don't have to write it. It's just sort of implied. So anyway, back to this problem. We square the square root sign, so that goes away. Now, if we square this over here, we're going to get x squared minus 4x plus 4. Now to solve, we have to set this equal to 0 and then factor. So we're going to get 0 is equal to x squared minus 5x. Oh, and those 4's cancel. All right, so in this problem, we have 0. Let's factor out the x minus 5. So in this problem, what we get is, well, 2 pieces. So we have x is equal to 0 and x minus 5 is equal to 0. So this one right here, we're going to get x is equal to 5. And then that one, we get x is equal to 0. So with these square root problems, we need to check to make sure we get the right answer. We can't just plug in. We did it in this previous one. I guess we should have. But basically, when you're doing these square root ones, whatever answers you get, so see here, we got 2 answers. We got x equals 0 and x equals 5. We have to actually plug these in to the original problem to make sure we actually even get the right answer. Not that there's no domain issue. Like, for example, we're allowed to plug in 0 here because that's not going to be a negative on the inside. And we're also allowed to plug this 5 into here because that's not going to give us a negative on the inside of the square root. We have to make sure that it satisfies this equation up here. So first, let's check for x equals 0. Let's check. So if we're checking for x equals 0, so notice that if we plug in 0, we are going to get the square root of 0 plus 4 plus 2 is equal to 0. We're just plugging in 0 for x. So this is the square root of 4, which is 2. So 2 plus 2 is equal to 0, which means 4 is equal to 0, but this is not true. So 0 is not an answer. So x equals 0 is not an answer. All right, so we don't take that answer. Now let's check x equals 5. So if we check x equals 5, so square root of x plus 4, so square root of 5 plus 4, plus 2 is equal to x, so is equal to 5. So let's see what happens here. So we have square root of 9, which is 3, so 3 plus 2 is equal to 5. So we have 5 is equal to 5. So that's good. So that means x equals 5 is an answer. So our only answer is x equals 5, and our x equals 0 is not going to be an answer. Okay, that takes care of all the homework problems. So I don't think we need to do any more together. Yeah, so it's okay. We can, let's stop here for the day. Yeah, so I'll put this video up on YouTube, and then I'll, see, whoever comes to class tomorrow, I'll see you guys tomorrow morning. All right, cool. Thank you.